Hi, hello everyone. I'm super happy to be here. So as Patrick mentioned, louder. Okay, I'm usually very quiet, so that's the first comment I get from everyone. So today I'm going to talk about how to detect malware with LLM, or at least my experiments. So I work at the company called iVerify as a research assistant. I am also super close to finishing my master's degree. Just a little bit more. So let's start with Mac malware. So Macs are everywhere, as we all know. They're getting more and more popular, not only with general users, but also companies. So they are also getting more exciting for the attackers. And the attackers are getting more and more sophisticated and faster too. And the same way as we are experimenting with AI to detect malware, the same way the malicious actors can use AI to create it. So this talk is actually part 2 of my talk at Objective by the Sea last December, where I was talking about my experiments with classic machine learning models to detect malware. And this time, my idea was to create a solution which detects malware using LLMs. But of course, for all of the machine learning and AI projects, we need data first. And I turned to the very trusty source, to the Objective-C malware collection, where you have so many malwares to choose from. And I just want to mention it here again, but I'm sure you all know this. If you want to run Mac malware or any malware, use a virtual machine. And how did the collection actually happen? So I used something called Apple Endpoint Security Framework, which is actually already built into the operating system. It was added with macOS Catalina in October of 2019. And it's also getting updated regularly. For example, this year in March, TCC events were also added. So this framework can capture events which are interesting from a security standpoint, which are, for example, when a program launches or when a file is open, created or deleted, and so on. So a lot of interesting events. And if you're interested about this framework, in Patrick's second book, there's a whole chapter dedicated to it. So I recommend to maybe read that. And how to run this framework or API. You can just run this basic, very simple command in the terminal, and you can already start capturing events. And to make this experiment fair, of course, I had to collect some benign data. And for that, I tried to perform activities that a malware would do. And I also collected them the same way as the malware data. And of course, we arrived to the second stage, which was the pre-processing part. This is my slide from December when I listed some of the steps I needed to do for the classic machine learning models to understand my data and to actually take it. So as you can see, there are lots of steps. With LLMs, actually, this is much easier because they do not require such a strict format of data. So when I was looking at it, I only noticed 2 interesting things or things to maybe do. So first, the logs were too big for the API to handle because there is a token limit or a context limit of how much input the LLMs can take. So one part of the pre-processing was to make this JSON shorter. And the other part was I saw some data which were redundant or low value, so I just removed those. Now we can move on to the large language models. So LLMs recognize patterns by turning words into numbers and using neural networks to learn which words and phrases often go together. So this is how it looks in a very simple way. They are called neural networks because they look very similar to the human brain, kinda. And this is the input. So the first part, objective for the we is and uses this network. These are the input layers. These are the hidden layers. There are so many like calculations and functions happening here. And these are the output layers. And based on this, it calculates what's the probability for the next word. By the way, these dots are called nodes. And in a model like ChatGPT, you have millions of these. So this is how it looks, basically. So I tested 3 models, all from ChatGPT. One was O4 Mini, which is a smaller but faster model. It's also good at reasoning. Then the second one was ChatGPT's 4.0, which is a faster model, but it's more for a general purpose, and it's not the best at reasoning. And finally, the O1, which is a deep reasoning model, but it's a bit slower. You can do all of these experiments in a locally as well, because ChatGPT's models are, of course, cloud-based. And you can use a tool like LM Studio, where you can really easily download different models and do the same thing. And we arrived to the third. Amazing. So we arrived to the third step of this whole process, which is prompt engineering. And this is a technique used to effectively communicate with LLMs and to get the desired output. I tested 6 different prompt times. The first one was a 0 shot, where we don't give the model any extra instructions. The second one was 1 shot, where we give the model 1 example. Then few shot, which is really similar to 1 shot, but you give more than 2 or more examples. Then chain of thoughts, where we give a model a step-by-step instructions how to think. Then negative, where we tell the model what we do not want to do. And finally, the hybrid, which is a combination of 2 or more types of these prompts. Now, here are my exact prompts. Yesterday at the training where we were experimenting, I didn't show you my exact prompts because I didn't want it to like influence you. But here's what I came up with. So 0 shot. You are analyzing JSON logs collected using Apple's Endpoint Security Framework API. These logs describe system-level events such as process execution and file operations. So this was the first part. I noticed with my experiments is very good to give a context about what the data itself is. Then your task is to determine if the JSON file indicates malicious activity. And then I ask for a really exact response format, I would say. So first, yes or no, whether malicious activity is present. And step 2, a very short explanation explaining your reasoning. And finally, here's the JSON to analyze, where the pre-processed data is then added to the prompt. So 1 shot is really similar to the 0 shot. As I mentioned, I just add 1 example, but I couldn't really add an example of a process. So here I came up with the idea to give a indicator of compromise. So that's what I did. I gave 1. Few shot, again, very similar to 1 shot, just more indicators here. And with chain of thought, here comes the step-by-step process how to think. So for example, first step, identify which processes are involved and where they were executed from. 2, check if the process is signed or known. 3, check if any known suspicious patterns appear. For example, code injection, persistence, excessive file access, and so on. 4, cross-check the behavior with common malware tactics. And 5, make a judgment if the behavior shown is consistent with malicious activity. And with negative prompt, again, here the job is to tell the model what we do not want. So here I said, your task is to avoid falsely labeling benign activity as malicious. Do not label anything as malicious unless you have a strong reason to do so based on the data. And finally, here only answer yes if the behavior clearly indicates compromise. And with hybrid, I combined a few shot and negative prompt, very similar to the earlier ones. And to evaluate the results I got from the experiments, So I tried every single prompt type, so these 6 prompt types with all 3 models and with all my samples. So you can imagine it was a lot. So to somehow start to get the results, I used something called a confusion matrix, where I was able to categorize each result into these 4 categories. So true positive meant that the model caught the malware correctly. False positive meant it was a false alarm, so it was flagged as benign, but in reality, it was a malware. False negative meant that it missed the malware, so it was a malware, but the model thought it wasn't. And finally, a true negative when it was a benign sample and the LLM correctly identified it as a benign sample. So then I used these super complex formulas to calculate the 4 metrics, which are usually used to see how successful classic machine learning classificators are. The first one is accuracy, which tells us how correct was the model overall. Then precision, which tells us the actual correctness. Recall, how many malwares were caught, and F1 is a balance score with precision and recall. So now let's talk finally about the results. So I found that actually zero-shot prompting worked really well overall. It actually caught all malware, and it only had few false alarms. So it only thought that it was a malware for just a couple of times, when it was actually a benign sample. Chain of thought and few-shot prompts also did very well, which means that if we give the model some additional context or steps, it actually helps it. One-shot and negative prompt, on the other hand, didn't work too well. They missed many attacks, but of course were, on the other hand, more cautious, and it had few false positives. Negative prompt wasn't really surprising for me. It makes sense, but one-shot, it turns out that it confuses the model instead of maybe giving it any additional information. So now let's talk about how can we use this in real life. This is also a slide from December where I was talking about how you can use pipelines to incorporate it into your existing systems. As you can see, it's a bit more complicated with classic machine learning systems and models. But with LLMs, it looks much nicer, right? So, takeaways. Even simple prompts like zero-shot work really well. More guidance helps, but it's not always better than just a simple prompt. Cautious prompts like negative prompts gave us less false positives, but also missed some actual attacks. Bigger models like 4.0 and 0.1 gave the best results, but 0.1, O1 is actually much more expensive than 4.0, so it doesn't really make sense to use it. So overall, the most successful in every kind of way was 4.0. But if you're okay with missing some attacks, then 4.0 mini is also, 0.4 mini is also completely fine. And finally, it's very important to point out that do not fully rely on AI. Maybe use it as a tool, maybe incorporate it as an additional layer, and then set up a system where you get notified if something is caught. And also be careful with sensitive data. So if you're using anything cloud-based, don't forget to anonymize things. Thank you. Yes?
Sure. Let me see how